Have you ever looked at a gummy bear and thought, what is this thing really made of? Because beneath those bright colors and fruity flavors lies a truth most people have no idea about. That wiggly gelatin dessert, the chewy candy you love, and even the pill capsules you might take, many of them start from something far less appetizing: animal bones, skins, and connective tissues. Yes, you heard that right. The base of gelatin isn't fruit, it's not a plant, it's collagen, a protein extracted from leftover animal parts in the meat industry. What's wild is that this leftover turns into some of the most widely used ingredients in food and pharmaceuticals today. It's in marshmallows, gummy worms, yogurt, jelly snacks, and even some frosted cereals. And yet, most people have no clue what's really behind the bounce. But how does something that sounds like waste turn into jelly? How is it cleaned, processed, and reshaped into something safe, edible, and even delicious? And, more importantly, does gelatin actually help your skin and joints? Is it as healthy as it sounds? Stick around. What you're about to learn will change how you look at candy forever. Long before gelatin became a key ingredient in desserts and candies, it had a very different and far more practical role in human history. In ancient Egypt, people discovered that boiling bones, skin, and tendons for long periods produced a sticky, gelatinous substance. They used it not for flavor, but for preservation and utility. It helped bind foods, prolong shelf life, and even create adhesives. The Romans, always extravagant in their feasts, cooked animal parts into thick broths that solidified when cooled. These weren't desserts, they were ways to make the most of every part of the animal. The resulting jellied meats were stored or served as delicacies. By the Middle Ages, gelatin had taken on new meaning. It became a mark of status among the European elite. Preparing it required time, labor, and massive amounts of fuel. Boiling bones for days just to extract enough collagen. Molded gelatin dishes weren't just culinary, they were decorative centerpieces at banquets, shaped into castles, birds, or mythical creatures. Then came 1682, when Denis Papin, a French physicist, introduced the pressure cooker, revolutionizing how gelatin could be extracted. This invention paved the way for mass production, though the process remained technical and slow. Everything changed in 1845. When Peter Cooper patented gelatin powder. Suddenly, the same substance that once took days could be made in minutes at home. It transformed from elite novelty to household staple. During the World Wars, gelatin's portability and shelf stability made it a key protein source for soldiers. It was compact, easy to store, and lasted for months without refrigeration. From ancient preservation to wartime nutrition, gelatin's history is full of reinvention, and it all started by boiling bones. Despite how it looks on a dessert plate, gelatin isn't something that grows in nature. It doesn't come from plants, fruits, or seaweed. It comes from animals, specifically the parts we don't usually think about eating. The key ingredient is collagen, a tough, fibrous protein found in the bones, skins, tendons, and connective tissues of cows and pigs. These tissues, often viewed as scraps or waste in the meat industry, are actually treasure for gelatin manufacturers. They're collagen-rich, durable, and incredibly abundant. After animals are processed for their meat, these parts are collected and separated from the premium cuts. While you won't find them in steaks or burgers, they carry the exact structural properties needed to produce gelatin. The selection isn't random. Manufacturers evaluate species, age, health, and diet to ensure consistency. A well-fed animal raised under specific conditions can yield cleaner, higher quality collagen, which affects the final taste, texture, and clarity of the gelatin. Next, the raw materials are washed thoroughly, trimmed of excess fat or flesh, and chilled immediately. Then, they're packed in refrigerated trucks and transported to gelatin processing facilities. If they spoil, the collagen breaks down, and the batch is useless. That's why timing, sanitation, and temperature control are crucial. What's fascinating is that many meat processors don't discard these byproducts, they sell them at a premium. What was once seen as trash is now valuable inventory for the gelatin industry. And it's not just for candy. Gelatin ends up in yogurts, marshmallows, soups, vitamin capsules, and even medical dressings. It's a surprisingly efficient system. From what most would throw away, comes one of the most versatile ingredients used in food and medicine today. Once the cleaned animal parts arrive at the gelatin factory, the real transformation begins. What follows is a carefully controlled, multi-step process that turns raw collagen into the clear, neutral-tasting powder we know as gelatin. The first step is soaking and pre-treatment. Bones and skins are submerged in either acidic or alkaline baths, depending on the source material. This step breaks down cell structures and prepares the collagen for extraction. It can take days, especially with bones, which are tougher to penetrate. After soaking, the material is thoroughly washed to remove any remaining fats or residues. Then comes the extraction phase, where everything is heated in large stainless steel tanks filled with water. This heat, kept between 55 degrees Celsius and 70 degrees Celsius, softens the tissue and slowly dissolves the collagen into the liquid. This liquid is thick, murky, and full of particles. So next comes filtration and purification. First, it goes through coarse filters to remove solid matter. Then it's passed through ultrafine microfilters, sometimes made from ceramic or synthetic membranes, to get rid of tiny impurities, fats, and minerals. At this point, the solution looks more like a golden broth. It's then sent through ion exchange columns, towers filled with synthetic resin beads that remove salts and trace contaminants. This step ensures a neutral flavor and long shelf life. Now, the goal is to concentrate it. The gelatin-rich solution is transferred to evaporation units, where water is removed under controlled heat and pressure. This turns the liquid into a thick, honey-like concentrate. Before it's finished, this concentrate is pasteurized, heated just enough to kill bacteria, but not enough to damage the collagen structure. Then it's cooled slowly and solidifies into a gel-like slab. The final physical transformation is all about drying and grinding. The gel slabs are extruded through perforated plates, forming long strands that are dried in hot, sterile air tunnels. These strands, called noodles, are then broken down and milled into a fine, dry powder, pure, odorless gelatin. But before packaging, every batch undergoes strict quality control. Samples are tested for clarity, viscosity, pH, and microbial safety. Only after passing all these tests is the gelatin approved for use. What started as animal scraps is now ready to become the base for gummy candies, marshmallows, pill capsules, and countless other products. It's one of the most precise and efficient transformations in the food industry, blending science, sanitation, and a surprising dose of chemistry. Once gelatin is processed into a fine, neutral-tasting powder, it becomes the base for one of the world's favorite candies: gummy bears, worms, rings, and more. But turning gelatin into colorful, chewy treats involves a whole different process, with its own science and surprises. Everything starts in massive industrial mixers. Gelatin powder is combined with glucose syrup, sugar, water, and citric acid. These ingredients are heated until they form a smooth, sticky, syrup-like mixture. Timing and temperature are critical. Too hot and the gelatin breaks down, too cool and it won't blend properly. Next comes flavoring and coloring. This is where the gummy personality is born. Whether it's cherry, lemon, cola, or sour apple, the mixture becomes vibrant, aromatic, and ready for shaping. The magic of gummy shapes happens using starch molds. Giant trays filled with cornstarch are stamped with shapes: bears, fruit, letters, or even cartoon characters. The hot gummy liquid is then poured precisely into these impressions. Now, the cooling phase begins. The trays are moved into temperature and humidity-controlled rooms where the candies sit undisturbed for up to 72 hours. During this time, the gelatin sets, giving the gummies their chewy texture and bounce. Once set, the candies are removed from the starch, cleaned, and dried again. But they're still missing one thing: shine. This is where coating comes in. Gummies are either rolled in sugar crystals for a crunchy exterior or coated with carnauba wax, a natural wax also used to shine fruit and even car parts. The wax prevents sticking and gives gummies that glossy, irresistible finish. Before reaching store shelves, The final gummies go through quality checks to catch any defects in shape, color, or texture. Then, they're packed in bags, boxes, or jars, ready to be devoured. From protein-rich collagen to sweet, chewy treats, it's an unexpected transformation that combines industrial precision with childlike joy. With all the industrial processing and surprising ingredients, you might wonder, is gelatin actually good for you? Or is it just another food myth wrapped in sugar? Let's start with one of the biggest questions. Does gelatin help your skin, hair, and nails? Yes, partially. Gelatin is rich in collagen, which is a structural protein found in our bodies. Consuming it may support healthier skin elasticity, stronger nails, and shinier hair. But results vary depending on how much you consume, your age, and how well your body absorbs collagen. Next, is it good for your joints? There's real science here. Studies have shown that collagen hydrolysate, a form found in many supplements and some food-grade gelatins, may help reduce joint pain, especially in older adults and athletes. It's not a miracle cure, but it can be a helpful addition to a balanced diet. What about calories and weight gain? Plain gelatin is actually low in calories and has no fat or sugar. The trouble comes from what's added to it, like in gummies or desserts. So yes, gelatin itself is diet-friendly, but many gelatin-based treats are not. Another surprising fact? Gelatin contains glycine, an amino acid that may support better sleep, digestion, and even reduced inflammation. It's one of the reasons bone broth, another collagen-rich food, has gained popularity in wellness circles. But not all gelatin is the same. Some types are more purified than others, and quality can vary based on how it's processed and sourced. In the end, gelatin is more than just a dessert ingredient. It's a protein-packed compound with real nutritional value, if consumed smartly. So, the next time you bite into a gummy bear or see a bowl of wobbly gelatin, remember, you're tasting the result of centuries of innovation, a hidden process that turns animal byproducts into something colorful, chewy, and iconic. From ancient kitchens to modern labs, gelatin's journey is one of science, history, and some serious transformation. If you learned something new today or see candy a little differently now, give this video a thumbs up, drop your thoughts in the comments, and don't forget to subscribe for more surprising food stories just like this one.